Alright, so today I want to talk to you about radicals. And a radical is made up of a radical symbol and a radicand. Now, I know you guys are looking at that going, what's she talking about? That's a square root symbol. That's probably what it's been called in previous years, but the true name for it is a radical symbol. The little check mark thing, the little square root thing that you see, that's the radical symbol, and I do want you guys to start calling it a radical symbol because we're going to talk about cube roots and fifth roots and that kind of stuff, so that makes it not a square root. It is a radical symbol. And then what you see inside it, whatever number that is, that's the radicand. So for square roots, this is tricky for some. You need to think to yourself, I need to find a number that I can multiply by itself, by that same number, to equal the radicand, to equal what's inside that radical symbol. So on your notes you see a bunch of numbers. Alright, the first one is, what's the square root of 1? What number times that same number equals 1? The only possibility, oops, hold on a second. Alright, the only possibility that it could be is 1. 1 times 1 is 1. Same thing, what's the square root of 4? What number times that same number times itself equals 4? The only possibility, 2. Square root of 9, what number times what number, that same number, is going to give you 9. Remember, it's not, oh, take 9 and divide it by 2. Take 16 and divide it by 2. No, because actually the square root of 16 is what people make the most mistakes on. It's not 16 divided in half. The answer is not 8, because 8 times 8 is not 16. What number times what number gives you 16? So that's going to be 4. I'm sure you see a pattern here, so you guys can go ahead and begin to fill in that list. There's a list that goes up to 400. Those you guys, by algebra, you guys should have those memorized, and I'll go over some tricks that you guys can remember those. Definitely you can get to 15, 20 is pushing you, okay? Alright, now we also have something that's called a perfect square, and this is kind of weird. It's the square of an integer. Now the examples are what's helpful. So for example, 49 is a perfect square because 7 squared is 49. Now if you want to do this backwards, all those numbers that you just had in your list, all those numbers inside the radical symbol, those are all perfect squares. Those are all different examples. What's a little bit tricky is estimating square roots. So let's say I want to estimate the square root of 19. There's 2 steps. The first step is you need to find the 2 closest perfect squares. The 2 closest, and look at your list. What does 19 come in between? 19 comes in between 16 and 25. 19 is greater than 16, but it's less than 25. So it's somewhere in between those. So now, what's the square root of everything? The square root of 16 is 4. The square root of 25 is 5. So the square root of 19 is somewhere in between 4 and 5. Alright, now just because it's in between 4 and 5 doesn't mean that it's, 4.5. All I want to do right now, and we're going to look at these in class in depth, find which one it's closer to. Is it closer to 4 or is it closer to 5? I don't want an estimation. I can take a calculator and do that. But I just want you to think, is it closer to the number 4 or closer to the number 5? So if you go back to what we had at the beginning, that number 19 is 3 units. 3 numbers, 3 digits away from 16. And 19 is 6 units away from 25. So what's it closer to? Is it closer to 16 or is it closer to 25? Hopefully you said it's closer to 16, so what that means is that the square root of 19 is closer to 4. Again, we will be talking about this more in depth in class. So I will see you tomorrow.